Hopefully you've had a chance to try out these practice problems. I'm going to walk through the solutions now. And if you haven't, just pause this video and give them a try. So first, we're looking at problem number 2. Identify each chemical as an ionic compound or a covalent molecule, and then write the name of the chemical. All right, so let's start at the top. First, we have I2. So this one is kind of tricky. So it's not a metal and a non-metal, so I'm starting to already think it's a covalent molecule. And iodine is a non-metal, and there's 2 of them, so I would say covalent. However, this is an important thing to note. It is 2 iodines covalently bonded together, but it's also just one element, and that's it. And especially our non-metals tend to form in their elemental form um, compounds that have more than that are covalently bonded together. And so you'll see O2, I2, F2, they'll be diatomic. Some of them, like sulfur, will have 8 sulfurs that actually make up its elemental form. Phosphorus is similar in that way. So actually, I would say that for A, it's an element. You can also say it's a covalent molecule. So be aware, if you're looking at something and it's just one element that's making up the compound, you're really probably looking at an element. All right, and so if we were going to name it, we would name it just the name of the element, right? It would be iodine. Okay, so for B, we have, it looks like calcium and then a phosphorus and an oxygen. So my eye is really drawn to the fact that there is a metal at the beginning, followed by non-metals after that. And I have more than one non-metal. And so that's my big red flag that I have more than one non-metal after a metal, that I have a polyatomic ion. And so I'm going to name this as a polyatomic ion. So my calcium is in the, so first that makes this ionic. So there's that. Um, that calcium is in the second column of my periodic table. So it has a predictable charge. My PO4 might not be something that I'm very familiar with. And so I'm going to run to my polyatomic ion chart and look it up. It's going to be phosphate. So I'm going to name this as calcium phosphate. And I don't need to manage the number of calcium or the number of phosphates because calcium isn't a um, transition metal, so it only has one possible charge. And I'm not naming this as a covalent molecule, so I don't need to identify the number of units I have. All right, next we have potassium and sulfur together. Again, another metal and non-metal, where that sulfur is my non-metal element, and that potassium is my metal. And potassium is in that first column of the periodic table. And so it's always going to be a charge of +1. It doesn't have the opportunity for multiple oxidation states or charges. So I am going to name this one in its most straightforward way too. So it's an ionic compound, and it's potassium sulfide. All right, let's look at D. So here I have a sulfur and a fluorine. These are both non-metal elements. And so I'm inclined to say that this is going to be a covalent molecule. And the way I'm going to name it is similar to the way I approach ionic compounds, right? So I'll start by naming the first element, which has a smaller group number, right? So sulfur is in group 6, whereas fluorine is in group 7. So I'll name that as it looks on the periodic table. There's only one, and so it would be monosulfur, but since it's the first named element, I won't include the mono. And then next I have fluorine, and I have 6 of those. And so that 6 is going to correspond to the prefix hex or hexa. So sulfur, hexa, and then my fluorine, which is the name of the element. I lose that INE and I put an IDE ending, so it'll be hexafluoride. Sulfur hexafluoride. All right, looking at E, we have niobium and we have chlorine. Now, niobium is a transition metal, kind of in that middle area. So this is first ionic because I have this metal and nonmetal, so it's most commonly ionic. And I'm going to name that niobium first, the way I see it written on my periodic table. But because it is a transition metal, it could have more than one possible charge. And so I'm going to need to give its charge in parentheses before I then name the chlorine, which will be my anion, so that'll be chloride. So let's figure out that charge on the niobium. So my chlorine is always going to be a -1, and I have 5 of them, so I have a total of a -5 charge. That -5 charge needs to be balanced out by just one of my niobiums, and so it's going to have a +5 charge. And so I'll use a Roman numeral 5 in my parentheses. Now, another way to think about this, determining the charge, is we can always also do the reverse crisscross rule, where I take my mole ratios and I make them the charges. So that 5 becomes a 5 over niobium, and I add a plus since it's a cation. And there's nothing in the niobium, so that's always equal to 1. And it becomes negative on the chlorine because it's the anion. And so that's another way to approach it. All right, F, we have boron and chlorine. Now, chlorine's a nonmetal. Boron is a metalloid. And when you have a metalloid and nonmetal, they typically form a covalent bond. So I'm going to name this as a covalent compound. Now I have 2 boron, and so I'm going to need to name that using my prefix. And so for 2, it's going to correspond to di. So this will be diboron. And then my last one is chlorine. I only have 1, so I'll do mono. And then I'll use that IDE ending for the second element, similar to the way I do in covalent compound or ionic compounds. Diboron monochloride. Right, so that's our naming practice. So now we're going to go the opposite way. We're going to take our names and interpret those into chemical formulas. So for our first one, we have ruthenium 2-phosphate pentahydrate. So the ruthenium, I can look up that element on my periodic table. I'll find it's a transition metal, which I should know just because the fact that it's followed by something with Roman numerals. So I know I have a ruthenium, and that Roman numeral 2 tells me it has a +2 charge. Then I have a phosphate. Now, this I am not going to find on the periodic table. It doesn't have that IDE ending. So that's a tip off that this is a more complicated ion than just an element. So I look at the polyatomic ion chart and I see, oh, it's phosphate, PO4 -3. Now, there's also a pentahydrate here. And so that's going to require that dot, right? And penta means 5, and hydrate means H2O. But I still need to resolve what my actual ionic compound is from these 2 ions. And so I'm going to do a crisscross rule to figure out how these will balance out to form a neutral compound. I'm going to need 3 of my ruthenium, and I'm going to need 2 of my phosphate units. So the way I'll write this out so it doesn't get confused with my other subscript in my polyatomic ion. So I'll have ruthenium 3, and then I'm going to use a parentheses because I need this 2 to apply to this entire ion, right? It's 2 of these entire units, not just the oxygen. And if I wrote it without parentheses, it would just tell me I have lots and lots of oxygen and not phosphorus. So I'll put in my polyatomic ion with that subscript 4 and then an end parentheses and a 2. And that means I have 2 of these PO4 units. Then I have my dot and my 5 co-crystallized waters or hydrates. All right. Next, hydrofluoric acid. So this is an acid, so I'll go to my naming conventions for acid. That just tells me there's a hydrogen that I'm going to write first in my my molecule. And then it says hydro, and then it has an element name and ICE ending. So it looks like the fluorine is written out as basically the same way you would for an anion. And that hydro is indicating that I have just a binary acid. So I have hydrogen, and then that fluoric corresponds to a fluor, fluorine on my periodic table. So I'm looking for an element that starts with FLUOR. And so my hydrofluoric acid will just be HF. All right, phosphorus trihydride. So I look up that first element, and it's a nonmetal. So that tells me I'm going to be looking at something that's covalently bonded. And so phosphorus is a P from my periodic table. And trihydride, that means I'm going to have 3 hydrogens. Hydrogen, if you take that OGEN off and put an IDE, that's how you get the second element's name in the overall complex's name. So I'll put a hydrogen and a 3. Right, and that's figuring out our chemical formulas. Let's do our last problem. We're looking at iron. It has charges of +2 and +3 commonly. It can also have other ones too, like +1 and +4. Um, and these both will form an ionic compound with oxygen. And so if I just named them, they would both be iron oxide if I didn't indicate the charge on the oxygen. And so the question is, name both possible compounds and give the formula. So let's take an iron with a +2 charge, and our oxygen will always have a -2 charge. And then we'll do the same thing for an iron with a +3 charge, bonding to an iron with an oxygen with a -2 charge. So I'm going to use the crisscross rule in general, and that would give me something like Fe2O2. These just, when they combine in a 1-to-1 ratio, will balance each other out because they both have a +2 or -2 charge. And I'm going to simplify this for my ionic compound. So it's just iron and oxygen, right? I could divide both of my subscripts by 2. So for my other one, when I do my crisscross rule, I'll have 2 irons and 3 oxygens. So I can't reduce that any further. So it'll just stay like that. So then naming these, our first one, we start with that element name, iron, and I'll put in parentheses the charge in Roman numerals. So this one was the +2. And then I'll end with the name of the anion with the IDE ending. And so the only difference between the names of these of these two is going to be the Roman numeral. Everything else will be the same. So this one will be iron 3 oxide. And it's important to remember that this Roman numeral is corresponding to the charge, and it's not corresponding to the subscript after the iron, but the charge of it.